Hello and welcome back for the second devlog from Project HorrorTown. I'm Layla and here's a roundup of what Jim and I have been working on for the past few weeks. One of the things that has been on our radar since earlier this year was a plan to adopt Unity 6 in the long term. There's stuff in Unity 6 which had appeal, such as various rendering performance improvements in the form of GPU resident drawer and some other cool stuff. As our game matured from tech demos into a releasable game, we also needed to settle on an LTS version, which supported the tech we had chosen to use. So over the course of the summer, we've been trying out various preview versions to see changes being added in and to check forward compatibility. The release of Unity 6 coincided with our annual trip to Scotland, so one of the first things we did whilst away was to upgrade. That went just fine, but we had been expecting no problems due to the experiments with the previews. In terms of day-to-day stuff we've been up to, as I mentioned, Jim and I finally got away for a sort of vacation at the end of October. We went to a modern self-catering cottage up in Scotland for 2 weeks. We didn't entirely down tools and stop game dev for that period, so it ended up being half holiday, half working away from home. That was by intention, as we knew the weather forecast was going to be mostly horrible, so we were expecting to be spending a fair amount of time stuck indoors rather than our usual hiking. Another reason we knew our hiking would be curtailed is that one of our dogs is getting very elderly. She's 15 and a half years old, she can't walk very far these days, and rather than leave her on her own, we take her along with us for walks. We have a purpose-made backpack for her, and that means we get to keep her company and she gets to see and sniff the world for a bit. The downside is that even a little dog gets heavy after a few miles. We brought the beefier desktop with us and an older monitor, but just to be on the safe side, we removed the GPU and packed the case with bubble wrap. It's a faff, but better than breaking an expensive graphics card. So back to game dev. As we were supposed to be half on holiday, we chose to do work that was more creative and try to avoid some of the more mentally demanding stuff. That didn't entirely work out, thanks APVs, more on that later. Anyway, we decided to work on the game world map. I actually came up with the idea for the layout of the town on a flight to a conference somewhere. I picked up a little notebook at an airport shop and doodled this, along with a whole host of gameplay ideas. We have been researching various small seaside towns in the northeast of the US, and we elaborated on my scribbled sketch to this more detailed sketch, and I got to play with my fancy alcohol markers too, so that was a win. We then started to build it out in Unity. The game is open world, so we needed to decide on what would make the world big enough to be interesting, but not so big that it would feel empty. Oh, and it needs to be performant too. For technical and gameplay reasons, we kept downsizing our map and we've settled on a playable area of about 2 square kilometers. A map of this size is still pretty huge, but means that we don't need to get so caught up in technically complex problems such as level streaming. This is our first 3D game and it's already hugely ambitious, so we've been trying to pick fights we have a better chance at winning. Here is the start of the lake and the river, and we have a lot of autumnal trees. Autumn is my favourite time of year. I love the colours, so the game is set on the run-up to Halloween. As we started to elaborate on the design, like placing rocks along the river edge, we realised that we would need to expand upon our existing LOD or LOD or level of detail system in order for the game to perform better. So let's talk about performance and draw calls. A draw call is where the CPU communicates with the GPU for each and every individual mesh it needs to draw on the screen, hence the term draw calls. Too many of these and your game chokes. One of the issues with kit bashing modular assets, I'm talking about the stuff you typically see for sale on the asset store, is that you end up making arrangements that represent hundreds of objects. If you're doing anything more than playing with these assets for fun, you realize that very quickly you run into performance problems due to draw calls. It's going to be a common issue people face, and we found it an interesting problem to tackle. Modular assets really do make it very easy to create new designs and to iterate on them, but for anything more than a small level, you'll discover that you quickly fall into performance issues. Early on, we had recognized that this was going to be a problem. As a lot of our level design revolves around self-contained buildings, we engineered a process for designing them from various layerings of prefab. For buildings specifically, we've written a custom system for managing the LOD of building. So for example, a basic version of a building will only have the exterior shell. The middle tier may include all the interior walls and floors, and a high detail tier will include all the other decorative objects such as furniture and props. This approach provided one way for us to show the low LOD shell variant at a distance, switching to the detail version when the player was nearby. This meant less meshes would be drawn, therefore less draw calls. Another advantage of using prefab layers to construct buildings is that you can make different variants from the same basic building. For example, a building with a different interior layout or different furnishings. However, even taking this approach, we still had performance problems. In our case, most of our assets are already low poly counts, so the need to use LOD systems in order to reduce the polygon density wasn't really much of a problem. So it was definitely the number of draw calls that was causing our performance issues. There are various approaches to mitigate this problem, such as batching techniques, but an approach we've partly adopted is to bake our modular assets into variants that merge the separate meshes. So, for example, a building that had walls made from perhaps upwards of 50 modular mesh pieces could instead be combined into a single mesh, all from within the Unity editor. This gives us the flexibility of being able to keep editing and changing our original modular designs, but then after a quick rebake, we can use a merged mesh version of the model instead. This is a performance benefit that not only improves the built version of the game, but also our frame rate in the editor. Another cool feature we added to this baking system was mesh decimation. This is a way to procedurally strip complexity from a mesh. In the case of our building LOD system, this means that we can now show variants for detailed nearby buildings, middle distant shell buildings, and far distant decimated ultra-low poly versions. So far, this approach seems to have made a big improvement to our game's frame rate. There is a similar problem for arrangements of objects that aren't necessarily a building. For example, being able to quickly plot 20 to 50 boulders around the side of a river is convenient, but you end up in the exact same problem with a rapidly rising number of draw calls. Traditionally, this is a problem that's resolved in the 3D modeling software. Your modeling person would make an arrangement and then typically export various LOD variants. These would then be imported separately and used in a traditional LOD setup. For us, we wanted the freedom to kit bash our modular assets directly in the editor without having to be too reliant on a 3D modeling package. Neither of us have anything more than an extremely basic skill set with Blender, so we needed to find a way that worked for us. To that end, we wrote a second general-purpose LOD manager. Compared to the building LOD system, it's much simpler as it requires less preparation of the model. To use it, we simply add all the objects we want combined into a parent object with a custom script on it. That script then merges everything into a new single mesh and creates a low poly decimated version. The final ingredient is a centralized manager script. The individual groups self-register with that singleton, and then this does the work of determining the distance of the object from the player and telling the object which LOD version to use. An experienced game developer will shrug this off as nothing special, but for us finding our way, it's a solution that worked pretty well, balancing easy win performance gains whilst retaining the convenience to just place or rearrange assets directly in context in the editor. So that's all coming along really well. Now to the actual bane of my game developer existence, APVs, or adaptive probe volumes. These definitely snuck into our holiday, and our idea of keeping the programming easy whilst away went out the window. So what is an adaptive probe volume? It's a fairly new Unity feature introduced at the end of 2022 that allows you to define volumes in which Unity automatically positions light probes around the level geometry. Those probes can then be baked and provide performant global illumination. Without getting in too deep on the subject, global illumination is about simulating how light bounces around a level to make it look more realistic. So, for example, if you have a dungeon tower with a window to the sky, even if there were no torches lit, you would still expect the room to be well lit from the daylight coming through the window and bouncing around the room. If the sunlight was streaming directly through the window and shining on a chair, that chair would be illuminated by direct lighting. The rest of the light that bounces around the room is known as indirect lighting, and this is what global illumination tries to simulate. Another way to visualize how global illumination changes the look of a scene is when a player approaches an open doorway to a building in the daytime. One would expect the entrance to be darker than the outside area. Without any global illumination, the interior would either be completely unlit, which makes for an unplayable game, or much more likely, everything would appear to be evenly lit, playable, but ugly. Simulating global illumination is computationally expensive, as it involves calculating how light rays bounce around the environment. With today's latest hardware, it's just about possible to calculate global illumination in real time. But to be honest, the results are often not that great, as frame rates usually take a massive hit. This is stuff that really needs to be pre-calculated in advance. Baked global illumination is not a new concept. In previous years, you'd almost certainly pull this off using some form of light map. APVs differ in a couple of ways, but the main differentiator from light maps is that they can illuminate moving objects, such as NPCs, and they readily support lighting scenarios. Lighting scenarios is a pretty cool feature because they let us bake the lighting at different times of the day, and then we can blend between those scenarios to show realistic time of day progression. The theory is great. Even working with small-scale demos is really exciting. However, working with APVs in a proper game has been a frustrating and extremely time-consuming experience. APVs seem to be really flaky, if I'm honest. In our experience, the inconsistency of the development experience has been infuriating. A bake can fail, or not fail, even without changing anything. The bakes themselves can gobble up all your computer's memory and crash it, or it can use a reasonable amount and work a treat. They can bake, but show weird artifacts like you see here in these screenshots, where they seem to have baked only certain cells of the APV. This turned out to be sky occlusion. Turning that off fixed this particular issue. But in general, there just doesn't seem to be any discernible pattern as to why they behave one way or another. We don't really know much about the inner workings, but we suspect it's to do with memory leaks or similar allocation problems. However, when the APVs do work, they really work well, as you can see here. The lighting inside the house is dark as we approach, and the ambient lighting inside is believable. For now, we'll just keep chugging along. I know that Unity is still working on APVs, so I hope they will improve with future engine releases. What else? Well, we've had some weird bugs, like this one here, where the building LOD system works fine in the editor, but fails miserably in a standalone player. This happened to be because we had written prototype code which tested whether a game object was marked as static. We'd use this as part of some process to determine whether that object should be drawn on screen or not. After a long process, several days, of attaching the debugger to the player, we eventually learned that this check behaves differently in the player than it does in the editor. We'll chalk that one up to experience. In general, when I look at where we were in development for the last video, we've come on loads, but the road ahead is still very long. So subscribe to the YouTube channel or become a Patreon member. Remember, there is a free tier to get regular updates on all the twists and turns that road has in store for us. Thanks for watching and see you next time.